Hi, everyone. We are the Quaker Houghton capstone team, and we are exploring the effects of impregnating sealants, fluid lubricity, and porosity of powder metal steel. Our team members are John Paul McCartan, Joseph Dignazio, Kyle Quaid, myself, Ryan Smith, and William Peterson. Quaker Houghton is the global leader in industrial process fluids and works with over 15,000 customers in over 25 countries to anticipate and overcome various machining challenges. Machining processes can have varying lubricant needs to achieve required quality. Powder metal steels are often filled or impregnated with a polymeric sealant due to the low machinability caused by the high porosity and composition of the material. Impregnation of powder metals can prevent leakage of liquids and gases and also yield a beneficial effect in machinability, often reducing tool wear and enhancing the quality of the machine part. So what Quaker Houghton wants to determine is the positive effects their sealants and coolants have on FC-0208 powder metal steel during an end milling process. To do this, we are going to machine impregnated IM3000 FC-0208 powder metal samples with two different fluids, QC7450 and HC8540, which is a high and low lubricity coolant, to assess the impact of impregnation sealant on machinability and lubricity effects from these coolants. Then we will machine non-impregnated FC-0208 powder metal samples with two different densities, 5.8 grams per cubic centimeter and 7.2 grams per cubic centimeter, while only using the Quaker Cool 7450 coolant to determine the effects of porosity on machinability. So the timeline for our project consists of researching machinability of powder metals, then developing testing operations, and then prepping the impregnated, the non-impregnated high, and then the non-impregnated low density samples, and then machining these samples, collecting the tool wear data, and then analyzing and drawing conclusions based on these findings.
In addition to our experimentation, the team did a literature review on the difficulties of machining press powdered metal to get a better understanding of the topic. The review focused on four main theories about what develops poor machinability. First being micro-interrupted cutting theory, the second hard inclusion theory, the third deformation cutting theory, and the fourth thermal conductivity theory. In our first experiment, we used two different coolant fluids when machining. The QC7450 has a higher lubricity and the HC8540 has a lower lubricity. As we can see from the graph on the left, the higher lubricity resulted in more gradual tool wear. From this, the team concluded that even when machining impregnated blocks, a higher lubricity fluid results in more gradual wear when compared to lower lubricity fluid. In our second experimentation, we decided to machine low and high density blocks to see if density affected tool life. From our collected data, we saw that the result of lower densities blocks resulted in longer tool life, which is contrary to what we found in our literature review. Because of this, the team cannot make a conclusion on the test. For further research in the future, we recommend using more high and low density blocks to get results to reach a conclusion.